Look closely at your hands and realize that every solid inch of your body is actually a ghost story told by mathematics. Our brains evolved to navigate a world of tangible objects, so we naturally imagine the universe as a collection of miniature spheres. Perhaps the most deceptive image in history is the schoolbook diagram of an atom resembling a tiny, spinning solar system. This tidy visualization is a total fabrication. The truth, uncovered by modern physics, is far more bizarre, a reality so detached from our everyday senses that it feels less like mechanical engineering and more like a fever dream of pure existence. Moving deep inside the atom doesn't bring you to smaller pieces of grit, but to a flickering domain where the very concept of a thing evaporates into a mist of chance. The primary culprit in this vanishing act is the electron. Traditional teaching portrays it as a little marble orbiting a sun-like nucleus. This mental shortcut fails because of basic laws of motion. In classical physics, a charged particle traveling a circular path would bleed energy constantly, crashing into the center in less than a heartbeat. The simple fact that matter doesn't instantly implode is our first hint that the planetary model is a lie. So, if the solar system analogy is broken, what actually exists down there? An electron, in its natural state, doesn't occupy a single point in space. Instead, it is defined by a wave function, a complex mathematical code representing the odds of a particle appearing at a specific spot during an observation. This isn't just a lack of data, it is the fundamental nature of being. Before we look, the electron possesses no fixed coordinates. It exists in a state of superposition, appearing everywhere at once within its allowed mathematical range. Reality isn't built of objects, it's constructed from patterns of possibility. Take a hydrogen atom's base state. It isn't a path, but a fuzzy spherical zone where the probability of finding an electron peaks near the center. There is no route or trajectory, only a map of where things might be. These zones are called orbitals, and they aren't physical containers, but three-dimensional standing waves of probability. Some look like balls, others like hourglasses or intricate lobes. When an electron shifts between these zones, it doesn't travel through the gap, it performs a quantum leap, an instant teleportation from one wave shape to another with no journey in between. This total defiance of motion as we know it is just the beginning. The strangeness is compounded by a dual nature. When a sensor triggers, the electron suddenly presents as a sharp, localized point. This is the core riddle of our world. Objects act like spread-out waves until they're watched, at which point they snap into a single location. The act of witnessing forces the universe to choose a side, collapsing a ghostly wave into a hard fact. How this happens remains the greatest unsolved mystery in science. The plot thickens when we consider the rule that prevents the universe from turning into a pile of energetic sludge, the exclusion principle. Electrons are fundamentally identical. You cannot tell one from another. This absolute anonymity creates a law where no two particles can share the same quantum address. This forces electrons to stack into distinct layers, creating the diverse chemical behaviors that allow life to exist. Without this cosmic traffic light, every atom would sag into a shapeless void, chemistry would vanish, and the cosmos would be a featureless desert. Peering into the nucleus only reveals deeper layers of abstraction. Protons aren't solid pellets, they're chaotic bundles of quarks, which are really just vibrations in quantum fields. Funnily enough, most of your weight doesn't come from the mass of these particles, but from the raw energy required to bind them together, a vivid proof of Einstein's famous energy-mass equivalence. The heart of the atom is a trapped storm of energy, mediated by the constant swapping of force-carrying particles. This leads to a radical conclusion. The world isn't made of particles at all, but of fields. The electron field and the quark field are the true foundations of the cosmos. A particle is just a temporary ripple or a knot in these universal blankets. An atom is not a set of objects, but a stable, interlocking harmony of vibrations in different fields. The hardness of a chair isn't caused by tiny balls touching, but by the intense electrical pushback between wave patterns of neighboring atoms. We are held up by the invisible walls of quantum law. Even more shocking is that an electron appears to have zero physical size, yet its probability cloud determines the size of everything you see. It possesses a spin, but since it has no volume, it isn't literally rotating. This spin is quantized, meaning it can only ever be up or down, never sideways. Energy levels in the atom are similarly stepped, like the rungs of a ladder, explaining why light is absorbed in specific, beautiful colors. Trying to see this world directly is a fool's errand. To look at something so small, you have to hit it with high-energy light, which immediately knocks the system into a different state. There is no such thing as a neutral observer. By the act of looking, we become part of the experiment. So what is actually inside an atom? The answer is unsettling. You won't find a more solid reality, but a framework of abstract math. The atom is a solution to the Schrödinger equation, living in a space of logic and potential. It's a cluster of quantized traits and a sequence of field ripples. From this chaotic web of uncertainty and leaps, the facade of solidity and life emerges. We are localized ripples in an infinite ocean of quantum fields. The universe isn't a machine made of parts, it's a fabric woven from the terrifyingly beautiful language of probability. When you touch a table, you aren't feeling matter, you are feeling the collective push of ghostly force fields, obeying the laws of the subatomic world. Your sense of solid is a macro-scale illusion, a trick played on your brain by micro-scale randomness. Every breath and every thought is a byproduct of this invisible quantum dance. The atom isn't a thing you can draw, it's a process, a set of instructions. In that move from substance to symphony lies the true humbling wonder of our existence. If you enjoyed this dive into the void, please hit like and let us know your thoughts on hard science theory. We are constantly searching for the bridge between the complex equations and the reality we experience every single day. This journey through the quantum realm suggests that our perception is merely a thin veil over a much more elegant and strange mathematical structure. When you consider the vast emptiness between these probability clouds, you realize that we are mostly made of nothingness, yet that nothingness is filled with the most intense forces in the known universe. It is a paradox that has challenged the greatest minds for over a century, and it continues to redefine what it means to be alive in a universe that is fundamentally non-material. Think about the implications of the wave function collapse for a moment. If observation is the trigger for reality to manifest as a physical point, what does that say about the role of consciousness in the cosmos? While some physicists argue for a strictly mechanical interpretation, others see the necessity of the observer as a hint that we are deeply integrated into the fabric of space-time itself. We are not just bystanders, we are participants in the unfolding of quantum states. This perspective shifts the atom from a boring building block to a dynamic, living interaction. Every time you look at the stars or feel the warmth of the sun, you are witnessing the result of these quantum rules operating on a massive scale. Nuclear fusion, the very engine of the stars, relies on these same principles of field interaction and energy exchange. The colors of a nebula, the structure of a diamond, and the electrical signals in your brain all trace back to the same set of probability maps we have discussed. It is a singular, unified story of patterns emerging from chaos. As we move forward into an era of quantum computing and advanced materials science, our ability to manipulate these fields will likely be the next great leap in human technology. We are beginning to learn how to play the instruments of the universe rather than just listening to the music. By understanding the atom as a process and a set of instructions, we unlock the potential to rewrite those instructions in ways we are only beginning to imagine. This is the frontier of hard science theory, where the abstract becomes the applicable. Thank you for being part of this exploration. The more we learn about the subatomic world, the more we realize that the ancient philosophers were right in a way. The physical world is the shadow of a much deeper reality. In our case, that reality is written in the language of quantum mechanics. Stay curious, keep questioning the models you were taught, and always